So okay, we'll see. We'll see. We'll see the problem, but before I will explain something, not something. So in some of the textbooks, I said that if you see, I said that vertical reactions are this type and rotations are this type is the positive things. That's why anti-clockwise moment is positive. Anti-clock rotation is also positive. Anti-clockwise rotation also positive. I taken like this. For the same thing, I developed a stiffness matrix also. But sir, some of the textbooks may be taken this also positive. Vertical reactions are this taken, rotation is clockwise. This is positive. Then only if you see, if you taken any fixed end moments, fixed end moments, this is PL by 8, this is PL by 8, you already know it. Sorry, previously we took it, this is a negative value. So something PL by 8 is a negative, PL by 8 positive. We taken, sir, we have a habit to do like this, sir. Suddenly, if you said anti-clockwise is positive, maybe some textbooks, mostly textbooks follow this. Some of the textbooks also follow this. Anything is you can take it, but sir, if you take in these directions, stiffness matrix is changing or not? No, no way. Stiffness matrix doesn't change. Sir, why it is, sir? Sir, just take an example. Just take an example. Stiffness matrix doesn't change. See, if it is taken this element, if you applied a unit deformation in the direction, unit deformation in the direction, it will go like this. It will go like this. You already know 6CA by L square, 6CA by L square. So how it is? This direction. Moment is in this direction. So forces in this direction. Okay. 12 EA by L cube. 12 EA by L cube. And now you can write it's K11. K11 is what? So this is the first direction. We applied unit deformation, and also force generated is 12 EA by L cube positive. Moment K12 same direction 6 EA by L square. K13 sorry, K21 K31. Okay, K121 K31 is again positive. K41 is negative. That's it, negative. So if you apply, if you see the previous class, previous class also, if you see the previous class also, these values are exactly same. Exactly same. Are understood? So the stiffness matrix doesn't change. The rotations only, if you taken these like thick, only these rotations you taken as a clockwise and anti-clockwise, and these forces, fixed and force vector, you have to taken as a clockwise is positive, downward is positive. You can take it also. This force downwards, okay, downwards is positive. This moment is clockwise is positive. You can take it as like what? Where is, like if you see this fixed end moment, if it is 50, so you have to take how fixed and force vector you have to take it. This is 50 into this L. You can take it as L by 8 is a positive. No, it's a negative. You can take it as a negative as usual. This is a positive, clockwise is positive, 50 L by 8. And reactions will come this like 25. So these you have to take a negative, because you taken like this one, you taken like this. So if you change this force vector, that's enough. No need to change the stiffness matrix. You can take like this also, you can take like this also, no problem. Final end with the same. Final end is the same. Okay, that's the one thing I have to say it. So second one of the student asked me, sir, you developed the stiffness matrix for this for this for this column, and later you said like this, later you said like what you said, v1 or m1 is multiply with these vector, these scalar quantities, multiply this, sir. But you develop like this only. You have to multiply this, you have to reverse the stiffness matrix. Someone asked, that is not a doubt. Okay, if you see, just just check the meaning, just check the meaning. M1 is, just check it, is M1 is movement in the direction is, just check it, is k21 or k22 or k23 k24. What is the k21 k22 k23? So 21 is the stiffness generated, otherwise force generated in the direction when the unit deformation in one direction. K22 k32, the force generated in the direction of three direction when the deformation is two direction. So if you just observe it, k21 multiply with delta 1, k22 multiply with theta 2, k32 multiply with delta 2 means what? The force generated in the direction of the 2 when the unit deformation in the direction of 1. So the force multiply with the displacement, force multiply with the displacement. The force generated, see, these are everything is related. Force multiply with displacement, force multiply with displacement, and just previously observed top, again you top it. So these are 4ea by 2a, 4ea by L means what? This is a k22 stiffness, 2ea by, this is a k24 stiffness. So just remove this vertical displacements. So the force generated, the force generated for unit deformation, force generated for the unit deformation are understood. K21 or K23 K3 means force generated for unit deformation multiply with the deformation. How much deformation is there? Force generated in the second direction when the unit deformation is there in the second direction multiply with how much deformation is there. Force generated in the direction of the second direction only. So those second related to this m1 are understood. Not these values. If you taken this column, if you taken it, is force generated in the direction of 1, force generation in the direction of 2, force generation in the direction of 3. These are not related to m1. So otherwise if you taken this column, these are not related to m1. So direction of 1, direction 2, direction 3, direction 4. But if you taken this row, everything is in the direction of this second only. K21, K22, K32. So K23, sorry, K21, K22, K23, K24. Everything in related to the second direction. Second direction means what? Second direction is this rotation or that movement or other movement. Everything in related to that M1 only. Okay, are understood? M1 only, everything related to the M1 when different directions, different locations, the stiffness, the deformation is there, the force is generated at the location of the M2. So that's the M. So the column doesn't represent anything. Column represents only 4 directions when certain place. So if we already developed here, see where it is. The column is, see, if the column is taken this T, only one direction, see this, only one direction, the different forces developed in 4 different directions. Are understood? So this is force developed in 4th direction, 4th somewhere. Only column, it's only the row represents, only the row represents the force generated in the direction of that M. When different locations unit change happen. So for unit change, those are the directions. You multiply with how much deflection is there. That represents, that is exactly idea. Okay. So someone asked yesterday, put a message like this: you developed a column, but you multiply with a row, but just see the meaning or inside, go through it. The column represents 4 different directions forces are generated, but we don't require. We write in a matrix form, like we write a matrix form, where it is, we write a matrix form, that's M2. The force generated M2, M or M represents these values. Force generated in the direction of M when different four diffraction directions give unit deflections. For unit deflections, these are the forces. You just multiply with how much deflection is there. You will get total force generated in the direction of M. Okay, so that's the idea. So that's one of the student put a message. That's those are two things I want to clarify it. Maybe some textbooks give like this, only doesn't feel that the stiffness matrix or flexibility matrix doesn't change. Only changes fixed and force vector, you have to change like this. Final rotations you taken as a rotations, thetas you taken as a what your sign convention you assume it, so take like this. Okay, so those two things I want to clarify. Now I will do a problem. I will do a problem in stiffness matrix only. Those are the classes, everything is stiffness matrix only, because I once again said there is no flexibility matrix of 4 by 4 6 by 6 doesn't exist. If you check it, if you search it in online also, you can't find it. Okay, but you can do the problems by individual. So how are individual, I will explain today also. Okay, so take the problem, very simple problem. $60 kilonewton meter and 100, this is the 3, 1.5, this is also 4 meters, 4 meters. Okay, take it like this, A, B, C. You can take it as a first element, a second element. Okay, this is the stiffness matrix. See, this is the problem, you have to do it. So by looking, you can directly say this. How many degrees of freedom is there? Degrees of freedom is only theta B and theta C. Okay, theta A is 0, theta A is 0, and horizontal you can remove it. Only 2 degrees of freedom is there, 2 degrees of freedom. Okay, 2 degrees of freedom, that's it, that's it. So finally you will get 2 by 2 matrix only. But how we can do, see. So individual you can write it. For first element, k11, k12, k13, k14. So k21, k22, k23, k24, k31, 41 for the first element. So the forces are already we developed. Second elements also same thing. Second elements also same thing, but the values are changing because 3 here is 4. EA is same. You can take it as A is same. Okay, EA is same. But the first element you can write like this. You can write like this. How can you write like this? K41, 42, 43, 44. So thetas are delta 1. So here if you see delta 1 also 0. So delta A is 0. Delta B is also 0. Delta C is also 0. Okay, you can delta A, delta B, delta C also 0. Okay, delta theta A, delta 2, theta B. That's it. Plus, what is this values? Fixed force vector. Fixed force vector are understood? Fixed force vector. What is the fixed force vector? So I taken as the same thing what I explain. These values are positive. Anti-clockwise is positive. Anti-clockwise is positive. I taken as so fixed. So you arrest every deformation. Find out the fixed force vector. So what are those values? What is those values? Can you say it? Can you say it? First one is 60. So this is values. What is that value? WL square by 12. WL square by 12. What is that value? This value is 80. This value is also 80. Okay, this value is also 80. And again, this is 100. This is value is WL by 4. 100 by 3 into 4. 100, 3 by 8. WL by 8. 100, 3 by 8. 8. Okay, but see, this anti-clockwise is taken as a positive. This clockwise is negative. This is positive, this is negative. So what is this value? This value is minus 37.5. See, plus 37.5 minus 37.5. You can change it. Yes, I said, sir, we already taken as a habit of doing anti-clockwise is positive. Anti-clockwise is negative. You can do it also. I will show you otherwise. And reaction also, you can take 60 into 4, 240 is 120 is 120. Here, it's a 50, it's a 50. So you can write it like this is 80, 80, see not 80, there it is. Reaction. So this is positive, upward is positive. You can write 120, 80, 120 minus 80. That's it. That's it. That's it. For second vector, these are the final vectors, final force, final reaction. V, we can call it as A. V, you can call it as A. Moment, BA. Reaction B with respect to A. Here, moment B. Sorry. Here, moment with respect at A. Here, reaction B with respect to A. Moment with respect to B with respect to A. Because only if you do it, it will give something moment. It will give MBA only. Okay, BA. So you have to differentiate BC or BD. Okay. Reaction also, if you taken it, for this one reaction will come, next span also one reaction will come at the same joint. That's why you differentiate. That's it. That is the first. That is the first element. If you taken as the first element. For second element also same thing. Yeah, second element also same thing. V B with respect to the second element, na? So BC, you can take it M BC, reaction VC, moment with C. Same stiffness matrix, but values will change. Because of the length. So I write same thing because 2 3 2 4 3 1 3 2 3 3 3 4 4 1 4 2 4 3 4 4. Again, the force vector, you can write it like, what is the, so 50 moment 37.5, 50 minus 37.5. Okay, so that's it. So if now two elements we write two, so for the assemble you have to add this value and this value. You have to add this thing with respect to this thing. If we add it for the add, if we add it, how can you do it? Just two equations. This is a one equation, this is one equation, just two equations you can add and again write in a multiple matrix form. That's the only thing. Because if you see here delta 2, here if you see where it is, okay, I didn't write here, I will write first. Here also if you take an is delta B, otherwise I will write yes delta A, delta B. Here also delta B and theta B, delta C, theta C. Those are the deformations. Plus those things values. Plus 50 plus 37.5, 50 minus 37.5. I write like this. So if you see, these two values are same. These delta b and delta b same, because here only one support. Finally it is 0. Okay, I will later. Okay, but the rotation also delta b and delta b is same. Those are the two same, and connectivity. So by that you can add this vector, multiply with this vector, and again these forces multiply with this vector, you get one equation. These are the two similar. So similar things you kept aside, you can write a matrix form. Already I said last class, already I shown you. See, kept aside, it will come like this. Okay, come like this. Otherwise you can directly see if you see. So see, k33 multiply with this factor. Here if you see, here you can see, here you can see what, k11 multiply with this factor. So both you have to add it, because delta b is same na? So same for every problem, same, yeah. So don't confuse or different complexity, nothing is there. So again if you see, k34 delta b, k12 is a delta b. That's only na? So and also if you see for this next MBA, k43 multiply with delta b, k21 multiply with delta b. So these first four add will these thing. That's the only idea. Okay, that's the only idea. Okay, so directly you can write it directly. You can directly write a assemble matrix. No need to write like this. You can directly write an assemble matrix every time. You can write it. Okay, so how can I write? Say v va va ma vba. Okay, vba. Now you can add this vbc, mba plus mbc, vc, mc. You can write it. And the flexible stiffness matrix is 6 by 6. 6 by 6 you can write k11 here this k11, here this for the matrix of a, for the matrix a values, first matrix values. These values differ for these values, because length is changing. Are understood? Length is changing. So that's why I will write, these are the white letters. See, white marker, these are this uh, another marker. Okay, this k11, k12, k13, k14, these two are zeros, because va is related to only delta a, delta b, theta b, theta b. Doesn't interested on theta c, because right is a 6 by 6 matrix. Here these are delta a, theta a. Just assemble it. Theta a, delta b, theta b, delta c, theta c. So for va, these four you can multiply with these four, sufficient. No need of these, doesn't depend on. Okay, those are the zeros. Okay, next these 2 1 2 2 2 3 2 4, those are the moment also. For this you have to add it both, k31, k32, k33, k34. But you have to add it for the bc. For the bc you add it k11, k12, k13, k14. Just add it and that's it. So mba, k41, k42, k43, add it, k21, k44, k22, k23, k24. Again if you see, kvc and mc doesn't depends on va, theta a. So you can write directly this 0, this 0, this 0, this 0, k32, 31, 32, 33, 34. K41, 42, 43, 44. That's it. That's it. These are the displacement vector, deformation vector is equal to the, this is a final matrix K. This is a final force vector, final force vector. This is a deformation vector. You can write delta plus fixed end vector, fixed end force vector, fixed end fixed. You can write this. So what is the fixed end force vector? Just add it. Add it. Nothing. 120, 80, 120, 80. Next again 120. But here is what? 50. Here is 50. Next here minus 80. Here plus 37.5. Plus 37.5. 50 minus 37.5. That's it. That's it. Every problem you won't do these things because you can directly come to this final matrix. You can directly comes to the final matrix, and also you can eliminate also. Okay, so that's it. See, now you can see this is the vector final matrix form. Now you can apply boundary conditions. Sir, what is the boundary conditions? Boundary conditions are delta A is 0. You already see delta A is 0, delta B, delta C, everything is 0. Everything is 0. And theta A is also 0. 0, 0. So for that you can strike out first column, first row. For the first, second strike out. For third also 0, you can strike out. For fifth also you can strike out. So only you have remaining these two values. Sir, this is a idea of matrix. Otherwise you can took the equation also, those are the two only come, because we will write only for, so this value and this value. These are the two values going to be 0. MC is 0 because delta is allowing. This MAB plus BA plus MBC also 0 because at that location the rotation is allowed. That is the equilibrium equation. So if you write those two equations, everything is, if you write MBA plus MBC, so this value multiply with this value is 0. This value multiply with this value is 0. This value multiply with this value is 0. So no need of that. So only this value multiply with this thing, this value multiply with this thing. You can write in equation form also, same thing. Yesterday I shown you. Okay, where I shown? Here I shown you. Everything is zeros. Okay, so you don't feel that is a matrix technique. Nothing, just a equation. So okay, that's it. Now we can see, you can write down. Now you can write down. See, 0, 0 only you can write down. This K44 plus this K422 of second matrix. 424 K42 K44 for the second matrix. Theta B and theta C plus, what is those values? Minus 80 plus 37.5. How much it is? It's a minus 42.5. Here is here is minus 37.5. That's it. Only those two are remaining. That's it. Now we have to find out these values. K44 is what? K44 is the 4EA by L. You already know it. 4EA by L. Okay. This is a K44 is 4EI by L of first matrix. First matrix, what is L? L is L is what? L is 4. K22 is what? K22 is what? 22. K22 here. K22 is what? 4A by L only. Or otherwise, see, a full matrix already there. This is a 4A by L. This is also 4A by L. You have to remember the matrix. but you can derive within seconds. I understand. You can derive the matrix within seconds because this derivation is very very simple. You already know these values. So the K144 is 4E by L. K22 is also 4E by L. Understood? So K22 is also a 4EA by L. But this is for the second element. Second element length is what? Second element length is what? Is a 3. Understood? This is a 3. So this is 4EA by 3. So you have to add it. What you will get? It's a 12. 4 outside. It's a 7. It's a 7 by 3 EA. Okay, 7 by 3. Next, next K24. K24 is what? K24. 24, 2EI by L. K24 is 2EI by L. Okay, 2EI by L. Everything is for the second matrix. 2EI by 3. K44 is again, it's a 4EI by L. 4EI by L. 4EI by 3. Okay, that's it. That's it. Now you can write 7 by 3 EI 4, so sorry, K K22. Okay, K24 is 2EI by 2EI by 3. Here also you will get, so if you know the K24, K42 also same thing, because these are everything is a symmetry matrix. Understood? Everything has a symmetrical matrix. No need write. Otherwise you can check it is that is also 2EI by L. Okay, 2EI by 3. This is 4EI by 3. Everything you strike out also, if it is a combined matrix also. Assemble matrix also is symmetric. Are understood? Assemble matrix also is symmetric. You can remember it. Okay. So multiply with theta P, theta C plus minus 42.5 minus 37.5 is 0, 0. Can you solve it now? Theta P and theta C? You can easily solve. You can easily solve. Can you solve it? EI by 3 you can now strike out 7 by 3, 2 by 3, 2 by 3, 4 by 3. Theta B and theta C is equal to 42.5, 37.5. You already know. So what is theta B and theta C? You can write in you can write as a matrix form. Otherwise you can write in a equation form. You can directly find out. Otherwise you have to write down the matrix form. You can apply inverse. If you applied a inverse of this matrix, it is idempotent matrix. You can directly write it like this. How can you write it? 3 by EI. This is a constant scalar quantity. And inverse, you have to apply the inverse. Inverse means what? So again, if you write a 3, no need at 3 here. Okay, inverse 7 into 4 minus 2 into 2. Inverse is what? Inverse is 4 minus 2 minus 2 7. You already know it. Theta B, theta C. See, not theta B, theta C. 42.5, 37.5. Otherwise, two equations, two unknowns. You can solve it. Otherwise, I will explain in a matrix form only. Now you can multiply with this factor. This is a scalar quantity. Multiply with this and multiply with multiply with this and multiply. You can get theta B and theta C. What is the theta B and theta C? Theta B is 11.87 by EI. Theta C is 22.18 by EI. So both will get positive values. Positive values means what? Anti-clockwise. Positive values means anti-clockwise. Are understood? Those are the anti-clockwise deformations. So how can you write down anti-clockwise? This is anti-clockwise. Okay. So this is also anti-clockwise. Anti-clockwise. So how it is deformed? It is the deformation. Anti-clockwise. Got it? Got that idea? That is the deformed shape. Once you know these two values, you can place it on any matrix, combined matrix, or otherwise individual matrix also same thing. If you know the theta c, see where it is, this VB, okay. If you know theta b and theta delta b is 0, only theta b is there. Only theta b is there, na? Only theta b is there. You can directly find out VA or MA. MA is, how can you find out? MA. MA is these values multiply with this vector. Everything is 0. Only 2, 4 multiply with theta b. This 80. You will get it? Okay. You will get it? Directly those two values place it in. This everything is 0. Strike out. Strike out. Only 0. So every matrix, you already know this matrix, these values you know. You can find out MA. You can find out VA. You can find out VBA. You can find out MBA. So no need of see, everything is no need of these values, because these three you can strike out. These three you can strike out, because first three you strike out. Only these values are remaining. See, these values, these value and this multiplication. For this value and multiplication. So you can only require this thing. Okay, you can directly write like this. You can write, or you can check it as a technique like VA MA VBA MBA is like K, or see, K1424 K14243444 multiply with theta B. You can just write like you can take it 50 37.5 50 37.5. What are those values? 50, sorry, 120 80. Okay, 120 80 120 minus 80. 120 80 120 minus 80. You can write like this, otherwise no need to write, you can directly do the problem. Theta B. Okay, so what is MA? What is MA? So that is important, na? If you know the MA, you can do the problem by your hand. Once one, what is MA? K24 is what? K24 is what? K24 is what? The matrix K24 is what? 2EA by L. Okay, 2EA by L. 2EI by L. So 2EI by L means what? First element, na? 4. First element is 4. 2EI by L. Theta B is what? Theta B is 11.87 by EI plus 80. Plus 80. That's it. So what is this value? If you know the EI value, I gave a EI value something like, how can I give? No need of EI. You can strike out. You can strike out 80 is a 2 5 something 85, and then it's a 85.938 kilonewton meter. 85 point kilo. Okay, you know the MA and MBA also. MBA also you can find out. Sir, VA you can also find out VA. You can also find out VA if you want to draw a shear force diagram also. Direct, if it's a 4 4. What is the 4 4? 4 EA by L. 4 EA by L. What is theta B? Theta B is 875 by EA plus minus 80. Okay, so minus 80. What is that value? Again cancel. Minus 80 plus 11 and the is a 68 minus 68.13 minus 68.3. So if you know the MBA, you already know MBC also same thing. because both two are same. Okay, MBC also same thing. Otherwise, the second maybe in second element you get any redundancy. MC also something as a redundant. You can find out that also. But here MC is a 0 because you already know that. Okay, so see, this is a positive. Positive means anti-clockwise direction. Negative means clockwise direction. So this is a this is a negative. Positive means anti-clockwise direction. Hogging moment. Understood? So once you already know, you can write down the you can write out the bending moment diagram. So 85 point is a hogging moment. So here it is 60 is a positive moment. The negative means clockwise. Clockwise means this is also hogging moment for that element. Okay, this is 85, this is 60, this is 0. This is a fixed end moments. This is fixed end moments. You can write down like same thing. You can write down like this is a uniformly distributed load. How much it is? WL square by 12. So WL square by 8. How much it is? I don't know. WL square by 12 is 80. WL square by WL square by 12 is 80. WL square by 12. WL square by 12. Maybe something you can find out. So almost time is over. You can find out. You will get it like this. This value is like this. That's it. If you know this value you can write it. Otherwise, this is very simple because now you can understand. You can find out the vertical reactions also. VA you can find it. VBA you can find out, and VBC also. See, VBC also you can find out for the next matrix. You can club it. VBA and VBC you can club it. You can find out the vertical reactions also. So otherwise you can take and simply supported this beam, this beam, this beam. So what is this reaction? This moment is 85. This is 85. This is 68. This is also 68. This is 0. You can take it and you can find out the vertical reaction also. This value, this value, and this value, this value by the directly matrix. By the matrix where it is by the second matrix. By the second matrix, if you see delta B, see delta B is 0. Theta B and theta C, two variables are there. You have to maintain two vector. Just no need to write again. Directly multiply with you can get it. So you will get it reactions. This is a VBA and VBC. You can write down the shear force diagram also. Can you write it? Can you draw shear force diagram also? By no need to again calculate by the moments. Directly you can also find out the force by the values. Okay, so that is the idea. That is the idea of the stiffness matrix. Okay, so now how the system is progress algorithm. If you know the meaning of you already know the what is the meaning of algorithm. So now we can observe it. So if you take in any matrix, any system problem, so many connections are there. Individual each element has a stiffness matrix, a deformation variable matrix, a deformation matrix, final end matrix, and it's a forced vector, for fixed end force vector. Okay, each individual element has certain equations, or each individual element has a stiffness matrix and variable matrix. Each individual, how many elements are there? You can add. Later you have to club it or combination or assemble the matrix. Assemble the matrix, you will get a 4 by 4 or 6 by 6 because total 6 variables are there. 6 by 6 matrix you will get it. In the 6 by 6 assemble matrix, later you have to apply boundary conditions. If you applied a boundary conditions, you can reduce the matrix. You can reduce the matrix into how many number of freedoms are there, how many number of degrees of freedom are there. Only 2 degrees of freedom is there. You can reduce it. So by looking the problem, no need to write these values, no need to write, directly. You can write this vector directly. You can write this na? because there is no calculation. These are everything is a fixed format previously. You can directly write by this. Can you write? That's the idea. You can write it. That's your capability. If you directly write it and you can find out these unknown values, once unknown values you find out, you can directly place it in the first matrix or second matrix. You can derive the remaining thing. Okay, are understood? That is the algorithm. That is the algorithm flow, boundary conditions. But if you see the textbooks, very low level textbooks, very low level textbooks or something YouTube videos, you can observe it. They directly write this value. They directly write this vector. How it is they write, I will explain tomorrow. And they didn't explain why it is zeros. Why it is zeros? They directly took it as a problem and they solve it. Once they got these two values, they use the slope deflection equations. They never use the matrix method. They once you got these two, they never use matrix. They directly took the slope deflection equation, they solved it. That is not an exactly matrix methods. Matrix methods is only the slope deflection method only. Those are the equations only. But you have to solve it matrix and you understand the algorithm. That is the idea. Okay, that is the idea. They directly solve this matrix here. See, they directly write it. They didn't give any explanation of why it is zeros. Once they got these two values, they write in a matrix, say slope deflection equation, they solve the remaining. They said that that's a matrix method. Okay, so no, so you have to feel that is a matrix. And now you can see, now another thing, one I have to explain it. once if you do once if you change the sign convention, once you change the sign convention, just observe it. Once you change the sign conventions, you may be get I will everything write it. You may be get it, these are the negative values. You may get these are the positive values. If you change the sign conventions, if you get these two are the positive, here you will get negative values. So here you will get negative. So here you will get negatives. Values doesn't change. Here you will get negative. If you change this, there is no change in flexibility matrix. I said stiffness matrix. Here you will get negative. So negative means anti-clockwise. If you change the sign convention, if you take in a clockwise is positive, anti-clockwise is negative. These two values you will get positive values. Here you will get negative. Here you will get negative. Negative means anti-clockwise. Same. The deformation shape is also not changeable. Not change. Understood? Here you will get negative. That's it. Here you will get, so this is negative, this is positive. So this value is negative, this value is also a negative. This value will get negative. Negative means anti-clockwise. Same thing. Where it is? Same thing. Okay. So which one is your choice? Message me. We will go through that only. Most probably, I said most probably in textbooks, anti-clockwise taken as a positive because the reason is this is good because there's vertical reactions every time is in upward direction only. Okay, anti-clockwise rotations are more possible chances. That's why they took it. This is a positive. Sir, we already have it to do. So clockwise is a positive. If you want it, we will do the problems here only. But I will do the problem in that way, anyway. But you can choose your way. I said you can choose. Conventions are sign conventions are your choice. It's not only in our test on our subject. Strength of materials to structure analysis to every time. That is your choice. That's why I never take more interest on sign conventions because some textbooks follow something, some textbooks follow something. Uh, that is your choice. That I inject the feeling that the sign conventions are not fixed. Those are the choice by the choice. So then only you can understand every type of textbooks. Otherwise I will fix that this is a good, this is the only choice. If you saw some other textbooks you feel clumsy, what is this something. Okay, so that's it. So everything values doesn't change, but your understanding will change. Our final volume solutions, everything is same, but you will come by this side to, you will come by another side, same answers will come. Okay, this negative, this will positive will come, this will negative will come, doesn't change at all much. Okay, so that's thing, this is the problem in stiffness matrix. So tomorrow I will show how textbooks, how very small textbooks, they directly write it, they directly write this 2 by 2 matrix. They don't want these 6 by 6 or 4 by 4 matrix, they doesn't want it. They directly took only two variables, only two degrees of freedom, theta b and theta c. They choose only two. By these two they can directly develop this, you can directly develop this and you can solve it. And once you solve it, you choose the matrix, the moment distribution, see slope deflection equation, they can solve it. And also I will explain tomorrow, I will explain that problem, and later I shift it to the flexibility matrix, exactly exactly opposite. Here there's a stiffness matrix, there flexibility matrix. Here this is a fixed and force vector, here there fixed and deflection vector. Deflections here also zeros, fixed and deflections vector. I will shift tomorrow. Okay, so that's it. If you have any problems, ask me.